I'm going to be solving problem 5.13. In part A, it asks how many unpaired electrons are in the octahedral complex ZnCl6 4-. And in part B, it asks how many unpaired electrons are in the tetrahedral complex CuI4 2-. Would you expect more unpaired electrons in the octahedral complex MnNH3 6 3+? Now, for part A, we first have to look at the oxidation state of zinc, and we know that Cl is has a -1 charge, and there are 6 of them. So in order to get to the 4- overall, zinc is going to have a +2 oxidation state. Now with that, we can find the electron configuration of Zn2+, and the original electron configuration would be Ar4s2 3d10, and then when we take away 2 electrons, it's going to be taken from the 4s orbital, which would give us Ar3d10, because zinc wants to hold on to its d orbital electrons. Now, knowing that the electron configuration is 3d10, we already know that all of the electrons are going to be paired, but I drew out the rest of the steps just so you could see how to do it. The ligand is a weak-filled ligand, which means that it's going to have a low splitting energy, which means it's going to have a high spin. And so when we draw it out, we see that all of the electrons are paired. Now for part B, we're going to start the same way, and we're going to find the oxidation state of Cu. Now we know I has a -1 charge, so if there's 4 of them, it's going to be -4. And to get to the overall 2-, we need Cu to have a +2 oxidation state. Now looking at the electron configuration of Cu, it is Ar4s1 3d10, and then if we take away 2 electrons, it's going to get rid of the 4s electron first, and we are left with Ar3d9. Now, again, we can kind of tell that there's 9 electrons, so they're all going to be paired except 1, but I drew out the rest of the process anyways. I is a weak-filled ligand with a low splitting energy, so there's going to be a high spin. And if we draw it out, you see there's 1 unpaired electron. Now, this is a tetrahedral complex, so the structure is opposite of the octahedral, but the work is still done the same. Now, with the second half of part B, we have our next complex, and NH3 is 0 charge, so if the overall complex is 3+, then Mn is also going to be 3+. And I drew out the original electron configuration of Mn, which equals Ar4s2 3d5, and then if we're lost 3 electrons, it's going to be Ar3d4. Now, NH3 is a strong field ligand, which means that there's a high splitting energy and a low spin. And if we draw this out, we filled out the bottom first because it's a low spin, so there's going to be 2 unpaired electrons. So the question asks which one you would expect to have more unpaired electrons, and it's true that in the second one in part B, there are more unpaired electrons.